Hello, and welcome to Applied Advanced Calculus. For those who go to Concordia, this is also known as ENGR 233. My name is Nathaniel Posesorsky, and throughout these videos I'm going to be covering weekly material for this course itself. So let's start off with week 1. In week 1, it's mostly review from linear. So you're going to be looking at projections, orthogonal projections, dot product, cross product. A typical example, which even showed up in my final exam this semester, was you're given 4 points, A, B, C, and D, and you're asked to find the area of the triangle. Well, if you subtract B by A and you subtract C by B, you could find your AB and your CB. Then, if you do the magnitude of that divided by 2, that gives you the area of the triangle. If they asked you for the area of the rectangle, you simply would have divided by 2. And that was the final exam question. But we're not going to focus that much on the review part for linear. You could do that on your own. We're going to really focus on what I believe is the main beginning for this course, which is vector functions. So let's say you are given a vector ABC and a point x0, y0, and z0. There are 3 ways to write vector functions. A parameterized form, which is in terms of t. You're going to write it as RT. You're going to take the vector ABC and write it as we did over here. Add the t next to it. And then you're going to take your point and you're going to add the point to that. However, the parameterized form is not finished until we isolate the x, y, and z values. X being over here, y this here, and z over here. So as I did on the right side. X, we're going to take a times t plus the x0 value. Then we do the same idea for y. We're going to take b times t plus the y0 value, and then again for z. That's the parameterized form. It is not complete unless you also give the x, y, and z, as we did over here. Now we also have the symmetric form. Now we also have the symmetric form. Symmetric form is simply taking the t value that we got in our parameterized form and isolating it. So for example, if we look at x equals to at plus x0, if we were to isolate t, we would get x minus x0 divided by a. And that t is the same as the t we use for y equals to bt plus y0. And so we just place the t's equal to each other and we get a symmetric form. We also have a Cartesian form. I put a star next to it because I myself rarely see it. And what it is, it's we take the vector ABC in terms of dx, dy, dz, and we just state it as the vector ABC. Again, it's very rare that they'll ask you for a Cartesian form. Now, what do we want and what do we need to do? If we're asked for the arc length, we're simply going to take the r prime that we found using our vector functions, do the derivative, then calculate the magnitude, and do the integral in terms of t. If we want the velocity, we're simply going to take r prime of t, the derivative. If we want the speed, then we're going to take the magnitude of the velocity. And finally, if we want the acceleration, we're going to take the double derivative of r of t, as in the rt that we found before. Now, we're also going to be asked to find the tangent, normal, and binormal. These, depending on your professor, you might have to learn them by heart for the quizzes. Maybe you'll be given a formula sheet. I can't guarantee you. If you want to learn them, go ahead. But the tangent equation, what it is it's the first derivative of RT, and then over the magnitude of that. So R prime T over magnitude of R prime T. And that gives you the tangent, otherwise known as capital T. The normal is going to be the derivative of the tangent over the magnitude of the derivative of the tangent, as we showed over here. And the binormal is simply going to be the cross product of the tangent and the normal. Now these are important because they help to find our curvature, which is essentially going to be like the main goal of the question. You might be asked to find simply the tangent or the binormal, but generally they'll just ask you, find the curvature. And to find the curvature, well, you need to know how to find the tangent. And so the tangent, as we said before, is r prime t over the magnitude of r prime t. And if we take the magnitude of the tangent and we divide it by the magnitude of the derivative of r prime t, we get the curvature. It could also be found by doing the magnitude of the derivative of rt crossed with the second derivative of rt divided by the magnitude of the first derivative of rt cubed. Now I know that might sound a little confusing, so you could just simply memorize the formula as I showed it over here. And there's also the 2D form, where we're going to have a function y in terms of x. You take the second derivative of y, and you divide it by 1 plus the first derivative squared, all of that to the power of 3 over 2. That's for curvature. They might also ask you to find acceleration, in which case we have tangential acceleration and normal acceleration. The tangential acceleration is going to be found by doing the dot product of the first derivative of rt with the second derivative of rt divided by the magnitude of the first derivative of rt. The normal acceleration is going to be found, it's kind of like this tangential acceleration, except now we're going to do the cross product of the first derivative and the second derivative of rt, take the magnitude of that, and then divide it by the magnitude of the first derivative of rt. Now all of that might sound confusing, so let's do an example. Over here we have rt as minus 2 sine t I, minus 2 sine t j, and 3 cos t k. So as we could see, this is a vector. If we do r prime of t, we're going to get minus 2 cos t, minus 2 cos t again, and minus 3 sine t. Whenever we have these kind of vectors, symbols over here, you could tell it's a vector. It's not parentheses, it's kind of like an arrow. That's the way I see it. That means it's a vector. Then we do the second derivative and we get r prime prime t. If we do the cross product afterwards of r prime t and r prime prime t, we get 6, 6, and 0. If we take the magnitude of that afterwards, we get 6 squared plus 6 squared, square root of that gives you square root of 72. Then we're going to take the magnitude of the first derivative of rt. That's going to give you 4 cos squared t plus 4 cos squared t again, and then plus 9 sine t. Forgot a little plus here. 4 cos squared plus 4 cos squared is 8 cos squared, and we know that cos squared plus sine squared is equal to 1. So we could simply isolate sine squared and get 1 minus cos squared t. All of that to the times 9. And we finally get our magnitude of r prime t to be square root of minus cos squared t plus 9. Finally, the curvature is going to be the value we found over here, square root of 72, divided by the value that we found over here, cubed. And that's your final answer. So I hope this helped you understand a bit better the beginning of applied advanced calculus. If this helped, make sure to leave a like, subscribe, and finally I'd like to give a shout out to Mech Bros Tutoring. They are the ones who helped me when I was taking ENGR 233. They're very helpful. They cover all sorts of midterm and final questions. They also do midterm crashes. They're very helpful, so you should definitely give them a shot. It's called MEC space bros space tutoring. You could find them on Facebook. So thank you everyone. I hope this helped, and I'll see you in the next video.